Cool. All right. So, taking it back a little bit, I know it's been a weekend. We're going to do our best today to do something that I know you've done before, but just it's a good tool moving forward. Again, this whole unit is tools for geometry. And so this is a very nice tool. And here's why. Put yourself back in history a couple thousand years, okay? In terms of history, this would have been where Egypt was the big center capital of the world, right? You have kind of these predominant nations, and the biggest one was Egypt because they had a big famine, and they were the ones who had the stored up goods to distribute across the nations. Well, they start building things, monuments, or actually they were tombs. They were called the pyramids. The pyramids were built by Thales as tombs for the kings or the pharaohs of their time. And, well, if I'm wanting to figure out how much brick that I would need to make to build a pyramid, well, I might want to consider the distance that I'll need to go. If I can figure out the distance and then the size of each one of those bricks, then I'm good to go, right? Because I can just do some quick math and I've got how much I need to make. So let's think about this. Distance. How do we measure one point in space to another one? By what metric do we do that? That's the question of today, is how do we go about finding distance? And this shouldn't be anything super surprising. I mean, we've seen this a little bit before, and so today shouldn't be anything crazy, but kind of giving us ways to handle distance. That's the goal of today. So, the definition, there's our first definition of this whole distance thing is, well, it's distance. And it says that, well, the distance between 2 points, wait, doesn't that remind you of an axiom? Right? There was an axiom we said that if I want to make a line, what do I need to have? And if you need to look back, you totally can. I need two something to make a line. Points, right? If I want to make a line, I need 2 points. And so the distance between 2 points on a line is the length. There's another fun word right there, length. I'm going to underline it. You're welcome to if you'd like. Of the segment between the points. If we think about what that says, it means I have a line, and the line can go on and on and on in either one of those directions, right? It has those arrows right here and here. You have arrows. And those arrows say there's more points out there. The distance that I'm concerned with is between my chosen two. Okay? When I took college geometry in college, it was interesting to me because it was pointed out that, well, when I'm trying to find distance in a regular life circumstance, what's really helpful is to choose one of those points to start at 0, right? If I'm doing woodworking or some sort of architecture building project, maybe with a 3D printer, I might automatically choose one of those to start at 0 because it makes numbers work a lot easier. So, just an interesting thing that this allows for. I need to choose 2 points and then find their distance. The coordinates of those points can be used to determine the length of the segment. So now we have options. We have some different ways we can handle this. So, here's one of them. If I just have 2 points, P and Q, in one dimensions, I kind of want to point that out. What is the name of that variable? If you're looking at that paper, what's the name of that variable for P and Q? I'm looking for the letter there.
Good morning, South Dearborn. In just a few moments, we'll be conducting our first fire drill of the 25-26 school year. This is the last time this announcement will accompany these drills. As in the past, we no longer immediately evacuate upon the sounding of a fire alarm. we encourage you to look around and evaluate your circumstances at any time a fire or other emergency system sounds an alarm. In the case of our schools, a multi-step process will occur when a fire alarm sounds. Our SRO will conduct a safety walk around the school while administrators will check the fire panels to determine why the alarm sounded. Through radio.
That is very true. All right, so we're going to get right back into this. We'll see how far we can go with the time we have. So there's a couple different ways that we can deal with finding the distance between 2 points. And the first one is the easiest. I can somehow take a ruler or other measuring device and line it up from one point to the other, right? And then when I do that, the distance that I find is, well, if you start at 0, it makes it easy. You go from 0 to 6, my length is 6. But assuming you don't start at 0, right? You start at any other number. Well, we would have to take the biggest number, like, I don't know, 8, and then we take the smallest number, like 2, and we subtract them, right? 8 minus 2 would be 6. And then maybe we make sure it's always positive, because can you have like a negative 6 for a side of a length? No, right? So we have to make sure it's positive. And that's exactly what this says. It says if P has coordinate x subscript 1, that just means it has this number. And then Q has x2, it's a different number, right? They're two different numbers. Then the length of PQ is equal to the absolute value of the largest one minus the smallest one. It's exactly what we're used to doing. It's just writing it in a more mathematical way. But notice something. It has another option, doesn't it? It says x1 minus x2. Is that possible?
Yes, because x1 could possibly be larger than x2.
Yeah, exactly. And it's the circumstance where we also realize, well, since it's absolute value, whether it's positive or negative, it doesn't matter because it'll automatically go positive. And so that's kind of what that's saying too. And so again, this is a way for us to figure out the length between points. Cool? So before I move into like an example of us using this, what questions do you guys have about this whole absolute value thing with lengths? Okay. Example 1. Well, it wants to find the length between C and F. It says find the length CF. What is the coordinate of C? I'll start with that. What's the coordinate of C? -1. This shouldn't be too hard at all. And then what's the coordinate of F? 5. Right? And now we just plug it into our equation we just came up with. We know that the distance has to be the absolute value of the biggest one minus the smallest one. So our biggest one was what? 5. And then our smallest one was -1. Very good. And remembering our integer rules, if I have 5 minus -1, what's actually happening there? 5 plus 1, right? Double negative cancels and it becomes positive. So it's really 5 plus 1, which is just 6. And that's literally it. Like I said, this should not be anything super difficult. It's more just formalizing it in a way that we'll need for this class. Okay? So what questions do you have about how we found 6? All right. You guys give this next check a try, okay? It says, use the number line to find AE, okay? I'll give you just like a minute or two. See what you can do. Do you need any water?
No, I have water.
Oh, okay.
I swear I was getting better, and then I went to a concert, and
It was so sick that you got sick?
it wasn't sick, it was weed.
Oh, I see. The skunk smell?
Yeah.
Yeah,
And it was just like breathing all that, and it was like not great.
I see. So I think you,
It was everywhere.
yeah, that's,
I don't think so. I don't know. I don't go to the doctor anymore, so I'm lumping this and everything.
all right, is it A, B, C, or D? C, right? We're trying to figure out A to E, and we know that E is at 7, A is at -5, and so we do 7 minus -5, which is 12. Bam. Very good. Go ahead and turn the page. I'm not going to spend a ton of time on this because it's a good question to ask, but I want to dig into some other practice that digs deeper into what I want to see come out of this group. Example 2 kind of takes that same problem and gives it a little bit of another step. It says, determine whether the line segment, remember if you just have that bar on the top, that just means line segment, C to B and D to F are congruent. Now remind me, we talked about that word a little bit last week. What does congruent mean?
Doesn't it have the same like length?
It's the same length, right? I want to make sure it's clear. They're not something that is equal, okay? I kind of foreshadowed this, that we were talking about it a little bit more. But here's what I mean. If I would write this on your notes right here. If I have this equals sign, right, the two little lines, equals says that one thing and another thing are the exact same thing, right? 1 equals 1. They're literally the exact same thing. In geometry, we're not always going to use just the equals sign. Because if I'm thinking of sides of a triangle or sides of a rectangle or something, those sides aren't the exact same sides. They're different sides. They just have the same length, right? And so instead of using this equal sign, we might instead use something that looks more like this, right? If you can see that, it's like two lines. Let me zoom in so you can see it a lot more clearly here. Can you see that a lot better?
Mm-hmm.
Okay. It's like two equal signs, and then on the top of it is like a weird squiggle. Technically, I think the term is tilde or something like that. I don't know. But it's like a little squiggle.
It used to be like the spoon, like a bout.
A little bit, yeah.
Around, like a bout.
It's very similar, right? They have the same length, they're just not exactly the same side, right? And so that's another tool in our arsenal here. When we're talking about the word congruent, right? Congruent, that's the symbol we're talking about. It's like a squiggle with the equal sign under it. That means that whatever two lengths we have, if they're congruent, then they have the same length. Okay?
But they aren't always the same size.
Right. They aren't the exact same side, right? But they are the same length. So like an isosceles triangle has two sides that have the same length, but they're not the exact same side, right? So they would be considered congruent, not equal. So I will make sure that's clear. What questions do you have about how the word congruent works? All right, and then let's use it, right? It says we need to determine whether CB, line segment CB, and line segment DF are congruent if they have the same length. So we need to figure out CB first. C has a coordinate of what? -1, okay. And then, well, B has a coordinate of what? -3. I think it put the -1 right there, so I'm just going to put the -3 here. Either way works. We kind of showed that. Either way will work. And so we have -3 minus -1. What is that going to be? negative 2, right? It's just integer rules. Negative 2, and then the absolute value of that, what is my final length? 2. Whatever number that is, it just turns positive. And now we need df, right? We know that d happens to be at 2, f happens to be at 5. It gives us the 5, so what am I going to put in that blank? 2. 5 minus 2 is 3. Absolute value of that is 3. So are 2 and 3 the same length? No. And so that's what it says. Because those line segment lengths don't equal each other, the segments are not congruent. Okay? So, this kind of lets us play with that new word of congruent in the context of geometry. So what questions do you have about determining segment congruence? Yeah, it shouldn't be too bad. All right. Let's get into this last check here. Okay, we're going to do the check right here. And then we're going to dig into really the one meat and potatoes element of what we're talking about today. Determine whether those are congruent. I think I've just about got everyone there. Are they congruent? What's the length of A to C? And the length of B to D? And so they aren't congruent. So you can put segments are not congruent. So again, this isn't going to be that big of a hard sort of topic with this piece. It's just more getting our minds around the fact that you can have multiple ways of doing the same thing. Okay. And I mentioned this earlier before the fire drill. This is one-dimensional. Do you guys play Minecraft? Do you know what Minecraft looks like? Okay. If I were to play Minecraft and I walk around the place, this. No jumping, no walking forward or backwards, but just like this. You see how I'm only moving in one direction here? Like this? Versus if I were to move forward or backwards, you see what I mean? This is considered one dimension, left to right. It's one dimensional. Now if I started going forwards and backwards, now that adds a second dimension to it. And then, better yet, I can jump up and down, right? Minecraft is a three-dimensional game. So I can go up and down, left and right, forwards and backwards. There's 3 dimensions. Since we're just going left and right, we are only going in one dimension. Hence, only using the letter X, right? That's the only letter we use because that's only the one variable we care about. I preface with that because what do we do when we have 2 dimensions? X and Y. And that's really the meat and potatoes of what I really wanted to get into today. Last Friday, we reviewed something very useful to us. What was that? It was like the whole thing where we got Skittles and stuff. The Pythagorean theorem, right?
I always go for that.
I believe that. See, they weren't sketchy Skittles, I promise.
Well, like, it was kind of sketchy.
Was it? Oh, I see. Yeah, I do have sandwich bags now, so in the future, if I ever do get sour Skittles again, they won't be sketchy, I promise. But we went through this thing with the Pythagorean theorem, right? And as a reminder, what is the Pythagorean theorem? A squared plus B squared equals C squared. Very good. And that's the Pythagorean theorem. Now, I want to kind of lead with this. You can use the Pythagorean theorem to also find distance. Because if you think about it, most of the time, what is the point of using the Pythagorean theorem? To find the missing length. And so if I have, for instance, 3 points, kind of like this, where they form a right angle, like that, right? If I have 3 points that form a right angle, I can use the Pythagorean theorem to find the length of sides if I know some distances, right? But you probably noticed I had to draw that in, right? It wasn't just given to me that I can do that. So how do I handle it if I don't have like other sides to compare it to? I only have the one side I'm dealing with. And this is the point of using something called the distance formula, okay? And that's what this says right here, the distance formula. This is one of those formulas that would be really nice to memorize, okay? I'm not as concerned about your ability to memorize it. I want to see you use it, so I might give it to you on a test. But this would be a good one to memorize because the faster you have it in your head, the less downtime you have when you're trying to solve problems, okay? And here's what it is. If I have a line segment in two-dimensional space, you see how I have x and y? That just means 2 dimensions. I can go left and right, and I can go up and down. So if I have the coordinate P at x1, y1, right? Again, coordinates, coordinate grid, that sort of thing we've done before, right? Since this is analytic geometry, some words we've used before. And I have Q that has coordinates x2, y2, just different points in space. Then the formula I use for the distance between P and Q is the square root, welcome home, the square root of x2 minus x1 squared plus y2 minus y1 squared. In essence, here's kind of what it's talking about. Oh, thank you so much. Really good, thank you. Thank you so much.
Thank you very much.
All right. So if we think about it like this, right? x2 minus x1, well, that's the same thing we started with at the beginning of today, right? Just that's from one point to another point, that distance. But notice there's not an absolute value there this time, is there? Right? The way that it handles it this time is it takes the number you get and multiplies it by itself. Then at the very end, it takes the square root of it again. Let's think about it. What's the opposite of adding? What's the opposite of multiplying? What's the opposite of exponents? Square roots, right? So notice it's just the opposite thing happening. So it cancels out, like it balances itself out like it needs to. But what's a negative times a negative? So if I get a negative in that space, it will go positive also, right? We don't need the absolute values there this time because it will make it positive, and then it'll take the square root at the end, so it balances out where it needs to be, okay? So this formula lets us find the distance between 2 points with different coordinates on a coordinate grid. So what questions do you have about how that formula works and why we use it? Yeah, like I said, that would be a good one to memorize because we will be using it a lot.
It's kind of just like slope, except you're doing the x with square.
Absolutely. Slope is a rate of change. It's a ratio, right? And so what that tells you is from this point to this point, how much is the average as it goes. In this instance, though, we're really more focused on the whole thing. all at once, right? Absolutely. That is very astute. Let's get into this. Find the distance between j and k, where j is 4, 3, and k is -3, -7. Okay? Let's break this down. jk, we need to use the distance formula. So the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? Well, if we think about it, what is my x2 and my x1? All right, let's start with the 2's. What are my x2, y2? -3 and 3. Let me say that again.
Wait, no.
x2 and y2. -3 and -7. Okay? So if I'm just plugging these things in, -3 is my x2, and then my -7, right, is my y2. I plug it into the corresponding spot. And then I need my x1, y1. So what's my x1 and y1? Okay, 1. Oh, yep. Is it 1?
No, it's 4 and 3.
Ooh, very good catch. 4 and 3. And then we just go through it like we've done before. So, -3 minus 4, right? We're $3 in debt, and then we go $4 more in debt. -7. And then -7 minus 3, right? We're $7 in debt, and then we go $3 more in debt. -10. And then, like I said, we're going to take that number and multiply it by itself. That's what that 2 power means. So, -7 times -7 is 49. -10 times -10, 100. And then for the final step, 49 plus 100. 149, take the square root. Okay? And if I were to use a calculator, I could find like the approximate estimate there. Let me bring this down a little bit so it's easier to see. Right, I could find like the estimate there, but the most accurate answer I would have to be the square root of 149. It is still a number, but it's not easiest to understand compared to some other ones. So, what questions do you guys have about how to use the distance formula?
So presumably this is better to use without simplifying the square root of 149, it's better to use the square root of 149.
That would be the best.
Exact number.
Yeah, I kind of mentioned this before, and I'll say it again. When we take numbers like a fraction or a square root or something like that, and there's a lot of decimals, what do we typically do with those decimals? Round. It's not the exact number anymore. You've estimated it to the closest it can be. If you're an engineer, that's totally fine. Okay? Because when we're doing stuff with engineering, it's not going to be perfect, but we need to make sure it's close. Right? Now, if I'm like a physicist or somebody looking at chemistry or biology, making medicine, right, I want to make sure that it is exact, because if it is off by any amount of error and then you take that medicine, not good.
So if it's not exact, it's better to just use the square root of whatever it is.
Yes, so if I were building a bridge, right, I want to make sure that's exact, because if it's not, and there's any little bit of error or leeway as cars are driving, right?
Like the bridge to
right? Versus, if I'm just trying to build a birdhouse. It's a birdhouse. Well, I guess you can make it the most, beautiful, accurate. So, you see what I mean, though? In the case of math, we're going to keep it as accurate as we can. On the SAT, they might have you round it or something like that, okay? All right.
But if they win you around it, they'll tell you.
Yeah, they'll say round to the nearest tenth or the nearest hundredth, okay? So, other questions? That's very, very good. All right, let's do it again. Again, just getting us some practice with this to see it happen again. We need to find the distance between point A and point B in this 2D space, okay? Let me move this down so you guys can see it. We need to find the distance between A and B, all right? Well, A, I'm just going to kind of write these off to the side so it's easy for us to see. A has what coordinates?
6 and then -4.
Negative 6 and negative 4. Very good. And then B has what coordinates?
5 and 9.
5 and 9. Okay? Very good. And now we do the distance formula. As a reminder, AB, right, that length, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So now we need to choose x2, y2. Which one do we want to use as x2, y2? Sure. So I'm just going to, if this is helpful to you, I like to write the x2, y2 under my numbers, just so that way I keep track of which number is which. And then if I have x2, y2, what am I going to put over negative 6 and negative 4? X1, Y1. Very good. Again, it's like you said, it's the slope thing, just keeping track of what we need. And now we just plug it in, right? I have the square root of x2, and x2 is 5, that's what we said. So it's 5 minus x1, which is negative 6. I like to draw these parentheses around my negative numbers sometimes just to keep track that that number is supposed to be negative, rather than looking and say 5 minus 6 on accident, right? Squared. And then plus my y2, that's 9, minus y1, negative 4, squared. And now I'm good. So, 5 minus negative 6 is 11. And then 9 minus negative 4, 13. And then for each of these numbers, we square them. We just take them times themselves. Does anyone know what that 11 times 11 is off the top of their head? 121. Very good. And then 13 times 13, 169. And then we add those and take the square root at the end. So 121 plus 169, right? 290, square root of that, right? Again, there's the square root over all of it, and we just keep it there. And so that's our most accurate answer, would be the square root of 290. You could simplify that, I guess, or make an estimate with a decimal, but that would be the most accurate answer. Okay? So, what questions do you have about how we use the distance formula, or what we did here? All right. We're going to skip example 4 here. It's a fun problem. It's just a real-life situation of using the exact same stuff with like some decimal numbers. So it'd be good practice. Tomorrow, I didn't go through it because this weekend was really good, but it was really long, and I'm really sunburnt, and I got home last night at like 10:30, and so I'm still making the schedule of what all is happening this week. Tomorrow, the plan right now is have a fun activity with this sort of thing that will then be able to give you one of those check your understandings. I'll have that last one we did graded for you as soon as I can. But again, just kind of that pattern of get some practice with this sort of thing to build up the skill. The last one we'll look at, this won't take too terribly long, is we're just going to look at the example 1 right here. We're not going to delve too deep. This is just kind of bookending it all. We just need to use the number line to find each of these. So J to L, how far is that? 5. It's easy peasy. It's really not hard. J to K. 3. Yep. K to P. 9. N to P. 2. Yeah. J to P. 11. Oh, I think you're close. 12, right? And then L to N. 5. So, It's multiple ways of just finding distance based off of our needs, okay? What this will let us do as we're moving forward is if we take some sort of shape, like a triangle, and put it into a coordinate grid, we know the side lengths now. We have ways to find it. Cool? So, it is 8:58. There's really not too much time to delve in deep into anything else. And we've already delved deep enough to everything else. So, tomorrow we'll have some good practice. I think the plan is this. It was an activity I did one time that went over really well. Do you guys like Kings Island?
I won't be here tomorrow morning.
Okay, that's okay. I'll have the recording of everything. The plan, yeah.